Okay, we're looking at radical expressions, and this time we're looking at simplifying our radicals. A product rule for radicals says when two things are being multiplied together under one root, we can separate those out. And so we're going to use this rule, but we have to look for two things being multiplied together. So for example, if we are looking at 45, 45 can be rewritten as the square root of 9 times the square root of 5. And now this allows us then to simplify the square root of 9, and the square root of 9 is just 3. So this simplifies the square root of 45 down to 3, the square root of 5. Let's look for some more examples. And with these examples, the idea is to always look to see if it's divisible by a perfect square when you're simplifying square roots, or a perfect cube when you're simplifying cube roots. So in this, we're looking at square roots. So what are our perfect squares? Well, 1 squared would be 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And you could continue down the list. So 24. Is 24 divisible by anything on our list here? Well, sure, we see 24 is divisible by 4. And 24 then can be rewritten as the square root of 4 times 6. And we can break that apart as the square root of 4 times the square root of 6. And the square root of 4 is 2. And we'll look at the square root of 6, but it's not a perfect square, so we know we're completed with this problem. The next problem, 6 the square root of 18. Well, the square root of 18 can be rewritten as the square root of 9 times the square root of 2. But we need to keep that 6 out there. So I could look at 18 then, rewritten as the square root of 9 times the square root of 2. Square root of 9 is 3, so that means now I have 6 times 3, the square root of 2, which is 18, square root of 2. So we multiply those coefficients when we take them out. So when simplifying a cube root, we're going to look for perfect cubes. 1 is always in everything, so we'll look at 2. Well, 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And again, you could continue this list on. So the cube root of 81, now be careful not to just look at that as a square root and say it's 9. We're looking at this as a cube root. And breaking 81 down as a cube root, we see that this is the cube root of 27 times the cube root of 3. And the cube root of 27 is 3. So this becomes 3, the cube root of 3. Make sure you don't lose that cube root sign. Our next example, 2 the cube root of 250. Well, 250 can be rewritten as the cube root of 125 times the cube root of 2. The reason I chose that 125 is I know that that is 5 cubed. So that means, in simplifying this, I would have 2, the cube root of 125 is 5, still with a cube root of 2. So 2 times 5 is 10, the cube root of 2. So that's how we simplify our coefficients, but now we'd also need to simplify our variables under the radical. And sometimes variables are not going to simplify perfectly. So here we have the square root of 16 m cubed. Well, we can rewrite this as the square root of 16 times the square root of m cubed. Square root of 16 is 4. But what is that square root of m cubed? Well, m cubed doesn't go in perfectly, but I could rewrite that as the square root of m squared times the square root of m. So simplifying this, the square root of m squared is just m. So I'm left with 4m, the square root of m. Looking at this square root of 200, x to the 5th, y to the 6th, I'm going to again break these down. Square root of 200, square root of x to the 5th, and the square root of y to the 6th. Square root of 200, I'm going to rewrite that as square root of 100 times the square root of 2. X to the 5th, well, I could take the square root of x to the 4th times the square root of x to the 1st power. Remember, when you're multiplying, you add, so that gets me to my x to the 5th power. And the square root of y to the 6th, I can actually take right now, that's y cubed. So now I just need to simplify these first two pieces. The square root of 100 is 10, but I'm left with the square root of 2. The square root of x to the 4th is x squared, but I'm still left with a square root of x. And I already simplified the square root of y to the 6th as y to the 3rd power. And now to finalize this, I'm going to write anything not under a root together. So I'm going to write this as 10x squared y cubed. And anything left under my square root, in this case 2 and x, I'm going to multiply again together. So that gives me 10x squared y cubed, the square root of 2x. Now looking at cube roots and simplifying those radicals, I'm going to start with the cube root of a negative 8. I know the cube root of a negative 8 is negative 2. The cube root of x to the 21st power, well, that seems pretty crazy, but let's go back and almost think of that as x to the 21st power to the 1/3 power, remembering that fractional exponent idea. And then we're just really looking at this as a multiplication. 21 times 1/3 is 21 divided by 3, or 7. So that becomes x to the 7th power. And now y to the 5th. Well, y to the 5th doesn't go in perfectly, but I can change that as the cube root of y cubed times the cube root of y squared. And simplify the cube root of y cubed is y. That means the only thing left under that cube root is a y squared. So I have negative 2x to the 7th y cubed, the cube root of y squared. And we can do this with fourth roots. Fourth roots, you're looking for something that multiplies 4 times into that. So that negative 5 is going to be left out, as that's our coefficient. Then the fourth root of 32. Well, I can rewrite that as the fourth root of 16 times the fourth root of 2, because I know the fourth root of 16 is 2. And now I have z to the 9th. Well, z to the 9th doesn't go in perfectly as a fourth root, but I could rewrite that as the fourth root of z to the 8th, because I know that will go in as a fourth root. Then the fourth root of z, which simplifies to z squared, the fourth root of z. So when I look at what's going to be outside of my root, I have a 2 and a z squared, but I can't forget about that negative 5. So I have a negative 10, that's that negative 5 times 2, z squared. And now what's still left under that fourth root? Well, a 2 and a z. So simplifying that problem, I have negative 10z squared, the fourth root of 2z.